chemical kinetics. Okay, right. Chemical kinetics is a branch of chemistry which deals with the mechanism of the reaction and which deals with the rate or speed of the reaction. Okay, means with how much speed a reaction will takes place is given by the chemical kinetics. And it also explains about mechanism. Mechanism means in how many steps one reaction will takes place. Means one reaction will takes place directly or it will takes place in step by steps will be given by chemical kinetics. Clear? So let us write the introduction points. It gives about rate or speed of the reaction. Rate or speed of the reaction. It also gives about mechanism of the reaction. It also gives about the mechanism of the reaction. Right? Okay. Now let us take one general reaction. I am taking a round bottom flask and I am adding reactant A and reactant B to the vessel. Okay, right, and I am heating the vessel. Right. When I start heating, both will react together and converted into products. Clear? Look at this. A plus B. A and B are the reactants. Both are combining together. As time proceeds, A and B converted to C and D or C plus D. Clear? Means as time proceeds, reactants slowly converted to products. Clear? At the beginning, at the starting of the reaction, amount of reactants is more, concentration of reactants is more at the beginning of the reaction, and at the beginning of the reaction concentration of the products is 0. Clear? Whenever we add A and B, products won't form immediately. It takes some time. As time proceeds, slowly reactants converted to products. Clear? Got it? So at the beginning, whose concentration will be more? Concentration of reactants. For example, at T is equal to 0. What is the meaning of T is equal to 0? T is equal to 0 means at the beginning, starting of the reaction. I am considering concentration of A is 10 molar, concentration of B is 10 molar at the beginning, starting. Clear? At that time, product's concentration is 0. For example, after adding A and B, and after heating for some time, for example, let us take some 10 minutes. After 10 minutes, what happens? Some amount of the reactants or some of the reactants will convert to products. Let us consider out of 10, 5 reactant molecules of A and 5 reactant molecules of B both will combine and converted into product after some time. So initially 10 we took. After 10 minutes, what happened? Out of 10, 5 A molecules are combining with the 5 B molecules to form products. Means I can write like this: after 10 minutes, 5, because out of 10, 5 are converted into product. So I can write like this. Clear? After 10 minutes. At the beginning, at the starting of the reaction, reactants concentration is more. As time proceeds, reactants concentration slowly decreases and the products concentration slowly increases. Now you tell me, whose concentration is decreasing as time proceeds? Whose concentration is decreasing? Whose concentration is decreasing? Reactants concentration. Yeah, and the products concentration is increasing. Clear? So can we use this word change in the concentration? Can I use the word change? Yes. Initially reactants are 10. After some time their concentration become 5, means changed. Concentration is changed. So we can use this word change in the concentration. Clear? As time proceeds, change in the concentration takes place. Maybe change in the reactants concentration or maybe change in the products concentration. Products concentration is 0. As time proceeds, products concentration is increasing. Clear? Right. Now let us draw one graph for the above experiment. Okay. On y-axis I am taking concentration. On x-axis I am taking time. See. This curve represents reactants because as time proceeds, reactants concentration decreases. This curve represents products concentration. As time proceeds, products concentration increases. Clear? Meaning of the curves, two curves. This curve represents reactants. This curve represents products concentration. Clear? Got it? Okay. Now based on this concept, means decrease in the concentration of reactants, increase in the concentration of products, we can define the rate. Now observe the definition of rate. Rate is defined as change in the concentration per unit time. Change in the concentration per unit time. Change in the concentration per unit time or in a particular time interval. Unit time or in a particular time interval. So we can write a expression for rate like this: change in the concentration by time. Okay. Now we can write the units like this: units of rate. Concentration and time inverse. In place of concentration, you can write capital M, molarity. Molarity is a concentration term. So you can write like this also. Clear? Concentration term, molarity, normality, all these are concentration terms. So you can write like this: molar time inverse. Clear? Right? Rate. Okay. Now let us calculate the rate. Okay. Observe these two graphs carefully. I am taking reactants concentration, and this is time. Observe carefully. I am giving some values. And so on. Time in seconds. Concentration, molarity, capital M. No, no. Let us calculate the rate. Let us calculate the rate between time interval. Let us say some 6 and 0 means 0 means at the beginning of the reaction, starting of the reaction, right? Or you can do like this. Just a second, wait. Let us calculate the rate change in the concentration between 1 second and 6 seconds in this time interval. Okay, right. At 1 second, what is the concentration? Tell me. What is the concentration? 8 molar. At 6 seconds, what is the concentration? Let us say some here 3 will present or not? 3. Okay, right. So between 1 and 6, between 1 minute and 6 minutes, we are going to calculate the rate. How much change in the concentration is taking place? We are going to calculate that. Clear? Right. What is the formula for rate? Change in the concentration. Change in concentration by time. Right. Change means final minus initial. Look at this. Right. Final means at 6 minutes. At 6 minutes, what is the concentration? 3. Initial. No. 3. In between 2 and 4, 3. 3. Okay. Final means at 6 minutes. Starting is 1 minute. Just we considered. Starting is 1 minute time, and after 6 minutes or at 6 minutes, concentration is 3. At 1 minute, what is the concentration? 8 molar. At 1 minute, see. At 1 minute, what is the concentration? 8 molar. So as time proceeds, slowly concentration decreased. Right? And at 6 minutes, concentration became 3. It's decreased. So final concentration is 3. Initial concentration is 8. Clear? By final time 6 minus initial time 1. Correct? 6 final minus initial. So here we will get a -5 divided by 5. That is equal to -1. Now let us understand the meaning of minus. This negative sign represents decrease in the concentration of the reactants. This negative sign is not having any mathematical importance. Clear? This negative sign represents decrease in the concentration of the reactants. Which type of change? Decrease. Clear? Right. So we calculate rate like this. Right? Change in the concentration by change in the time. Final concentration minus initial concentration by final time minus initial time. Clear? Now you tell me, we calculated rate in the time interval of 1 and 6. Correct? Now means some gap is there. Some 1 and 6, some considerable gap is there. Now you tell me, can I calculate rate between this time interval 1 and 5? Can I calculate or not? Yes. Can I calculate between the time interval 1 and 4? Yes. Between 1 and 3? Yes. Between 1 and 2? Yes. Between 1 and 1.5? See, I am just decreasing the time interval. First 1 and 6, 1 and 5, 1 and 4, 1 and 2, 1 and 1.5. Now the time interval is very less. Means almost the two points are joining together. Clear? Time interval is more. Clear? Large time interval. First I calculated change in the concentration of reactants between large time interval. Slowly I am decreasing that gap. First 1 and 6. I assume I calculated rate between 1 and 5 time intervals, 1 and 4 time intervals, 1 and 3 time intervals, 1 and 2, 1 and 1.5, 1.2, something like that. Means if I calculate the rate between 2 times with very negligible difference, 2 times means 1 and 1.5, means 0.5 gap only there. 2 time values with a small gap, small difference. That rate is called as instantaneous rate. Okay, if rate is calculated with a small time interval, that is called as instantaneous rate. Now this is called average rate. Average rate. Average rate means the rate is calculated with a large time interval. Okay, average rate and instantaneous rate. Instantaneous rate. Clear, both of you? Right. Right. I can represent that instantaneous rate like this. Zero, any 2, 4. We are decreasing the time interval, right? After some time, the 2 time values coincide with each other and appears like a point. Appears like a point. Let us draw one tangent at that point. How we got this point? By decreasing the time gap. Time gap, right? First we calculated between 1 and 6, 1 and 5, like that, like that, like that, like that. We decreased that gap. Means the 2 time values almost coincides with each other and appear like a point. Let us draw the tangent. This graph represent instantaneous rate. Instantaneous rate. Clear? Any doubt in this? This is tangent. Clear? Now let us write the symbols for average rate and instantaneous rate.